When you're doing algebra, there are some functions that you just need to know. The first one is a line, and we'll call the linear function. The linear function is y equals mx plus b, but the base of it is just y equals x. It's also called the identity function. And so it's a line right here. We're going to also call it the identity function. And y equals mx plus b shifts that function up or down. So it could move up, it could go down, it could do lots of things, but that happens when you put in a different slope and whatever. But y equals x is your beginning, your identity function. Number two, you should make a note of these and you need to learn them. Practice drawing them and thinking about what they are. Number two is a quadratic function. A quadratic function is also called a parabola. It's used, we work with it a lot in college algebra and in other higher classes. So quadratic function is also called a parabola. The equation is y equals x squared. Now when we look at these x and y axes, which should have arrows on all ends, laziness popping in, sorry, we have a U-shaped graph. So it makes a U. Now this dot right here, we're going to call it the anchor point. And this point, it is called a vertex. So the vertex is at 0, 0. I'm going to call it either a vertex or an anchor point because as we learn transformations, we're going to look at how they move around the graph. All right, number three. Number three is a square root function. A square root function is the square root. So y equals the square root of x. So we look at our x and y axes. It's a crooked axis. I guess it doesn't matter, but it's a crooked axis. Here our anchor point is going to be at 0, 0, and it's going to be one side of a parabola. Just a little hint here, if you were to square both sides of this, you would get y squared equals x, which would give you a sideways parabola, but that is not a function. So we are only talking about library of functions, so that's not important in this case. But you can see how it's the top half of a sideways parabola. All right, number four. Number four is a cubic function, which means y equals x to the third, also read as y equals x cubed. Now this graph is it's a very tall graph. If you think about if you were to plug in a chart, 2 to the third power is 8. So when x equals 2, y equals 8. When x equals 3, y equals 27. So it's a graph that goes like this, very tall, very quickly. A lot of students struggle with how to draw it or sketch it. So you do a half a sideways parabola up and a half a sideways parabola down. And right here, our anchor point is 0, 0. Notice that we have an anchor point on every graph because in the next section, in the next part of this lesson, we're going to learn how to transform them. So this is an important concept here. Number 5 is the cube root function. Just like it sounds like, it's the cube root. So the equation is y equals the cube root of x. And it's the cube root of x. It's the inverse of x to the third, so it's the sideways version. So a lot of students, again, struggle with this, kind of draw half a parabola, half skinny parabola this way and the other way. So that would be the cube root of x. Number 6 is the absolute value function. So here we have absolute value. Absolute value, y equals the absolute value of x, is always positive because you're talking about how far a number is from 0. So when you look at this side, the absolute value of 1 is 1. The absolute value of 2 is 2. Now on this side, normally our line would be, if you think about the identity y equals x, it would go down like this. But absolute value is always positive, so it reflects it up over the axis. That's where this comes in. That's where this comes from because absolute value is always positive. So here we have a vertex, also called an anchor point, but we can call this a vertex. It really truly is. and it is at 0, 0 as well. Number 7. Number 7 is the reciprocal function. If you think about it, a reciprocal, it means that you flip the number or the fraction. So this is y equals 1 over x. Now what's interesting about this one is that we don't have an anchor point. What we have here is when we look at this graph, we have vertical asymptote because you can't divide by 0, and a horizontal asymptote, which we get into more in pre-calculus. But this graph kind of hugs those asymptotes. And when the x value is positive, the y value is positive. And when the x value is negative, the y value is negative. So the sketch of the graph looks about like this. Number 8, we have the reciprocal squared function. So this is y equals 1 over x squared. And so we have vertical asymptote here, because you can still not divide by 0, and a horizontal asymptote for the same reason here. Now when x is squared, y is squared. Now my sketch looks very similar, but it's a little taller on this version because it's squared, it's kind of stretched. And then when x is negative, y is still positive because it's squared. So this one's actually symmetrical with respect to the y-axis. It looks the same on both sides of the y-axis. And then number 9. Number 9 is our constant function. This is y equals some constant c. Or you can just say y equals some number. And so here we have just some graph at whatever value c is. So if it's 5, it's here. If it's 8, it's here. If it's 12, it's here. If it's negative, it's below the axis. So you should practice drawing these. What you should do now is pretend to take a little pretend quiz. So we're going to call this a pretend quiz. And with the first time you take it, look at your notes. The second time you take it, try not to. But sketch the following graphs. That means draw them about the way I did. So a sketch means you don't have a graph or points or anything. You just give an idea of what the graph looks like. So let's say 1 y equals x squared. Number 2, y equals the absolute value of x. Number 3, y equals the square root of x. Number 4, y equals 1 over x. And number 5, y equals x to the third. So pause the video and draw them all. I'm going to give you a minute to pause. Okay, so I'm going to assume that you paused it, you drew your graphs, and then you can pause it and check with mine. And let me know if you have any questions, and have a great day.